I'm Jonathan Aronson on the COM faculty and also on the IR faculty. And I thank Peter Monge for sort of ceding me chairmanship for the day. He'll take it back next week of the Monday seminar. I'm delighted that today we have Nicholas Economides from the Stern School of Business at NYU joining us. Nick has also taught at Stanford, Columbia, has a degree from Berkeley, so we know he's overeducated. His primary work has been on the economics of networks, and he tells me he has boldly offered to teach a course this fall on social networks, which he figured he'd get 20 MBA students for, and they've cut it off at 51. So now he has to learn about social networks. In addition, he works on law, public policy, antitrust, regulation, and antitrust. To many, he is probably best known for the blogs that he runs, The Economics of Networks, which he tells me The Economist has named the 4th best economics blog currently existing. He trails his colleague. He's only 2nd best at NYU, though, because Rubini is on the same faculty, along with, we think, Krugman and National Bureau of Economic Research. So he's doing pretty well there. In addition, he gives away money, which is a good thing to know, with his Net Institute, which is Networks, E-commerce, and Telecom Institute, funded by corporations that actually provides a fair amount of money. And as is appropriate to study someone who studies the economics of networks, Nick is one of the most networked people in the business. So it's entirely appropriate that he be here today, where his topic for the day is the economics of network neutrality, a paper that has circulated, but it gets us a topic that is both very important and still very timely.
Well, thank
Nick,
you very
welcome.
much. Thank you very much, Jonathan. This is thank you. Well, you can clap after.
If you want.
Thank you. Well, it's a great pleasure to be here. I've been here for 3 or 4 years, so it's great to be back. Okay, the Net Institute is what gives money typically to assistant professors, and I see in the audience at least one recipient. Maybe there are others, and I don't see everybody very well. Okay, so I won't go into the details about who I am. Already Jonathan introduced very extensively that. I want to talk about this issue of network neutrality, or sometimes shortened to net neutrality. There is one seat here if anybody wants to be close to me. In the back. Okay, let me, first of all, I'll try to, okay, we circulated the paper that I currently am writing. It's almost finished with Ben Hermelin and Berkeley. That's a kind of a theoretical paper which some of you might have been brave enough to read through. But I'll try to talk about half the time I'm allocated to policy issues, and then the other half is going to be a non-mathematical explanation of what we do in this paper, and then I'll be open to your questions. So the most fundamental thing to think about is that when you have a network, you have the possibility of pricing on both sides of it. So, for example, you can have Adobe Acrobat and Reader, and Adobe makes one side pay, or you can have Yellow Pages in which only the advertisers pay, or advertisers and users on the internet search engines where only the advertisers pay, and newspapers can be either way. And then you can have many different setups: computer clients and servers, operating systems and applications, game platforms and games, authors and readers in academic journals, in which there is the possibility of collecting from both sides. So this is a kind of a general issue, and it's not really just the internet related. And when you look at the world of these vertically disintegrated setups which allow for two-sided pricing on a network, you find that in some cases you have one party subsidize the other. For example, in computer systems, operating systems such as Windows subsidize applications, and I don't mean just the Microsoft applications, subsidize applications in general. On the other side, on the other hand, game platforms collect from software developers. I won't go into the Visa MasterCard problem, it's a bit more complicated. The newspapers could, right now, most newspapers are distributed not for free, but they could go free and so on. So in this general setup, there is the issue of, can we regulate, should we regulate, and if we do regulate, which side do we regulate, one or the other, and under what conditions do we assume the other side operates when we regulate one side? So this is kind of the general problem. So it's possible that people might say, in some industries we should not regulate at all, but in other industries maybe we should. Okay, so this is kind of the schematic of the various, of the basic problem. You have someone in the middle, a platform, and in the context of the internet, this is going to be an internet service provider, like somebody who provides you, gives you internet service, such as AT&T or Verizon or a cable company. And on the top, you have content providers who are people like Disney, but it can also be application providers, people like Google or Microsoft or Yahoo. And on the bottom, you have consumers. And the problem is a bit complicated because there are three different prices. There is a subscription fee that consumers pay to the platform, to AT&T. There is a potential fee that AT&T wants to collect from content providers, which is practically speaking, since the beginning of the internet, zero, but AT&T wants to make it positive. And then there is potentially another price that the consumers pay to content providers, or at least some content providers. They might not pay Google, but they pay Disney. So this is the basic setup. Now the specific setup on the issue of net neutrality is essentially the following. You have a long distance part of the internet, which we typically call the internet backbone, which we consider to be competitive. Competitive means that the prices are close to marginal cost. And why is it competitive? Because it's undifferentiated product, long distance, many providers, and so on. Not really that many, but the undifferentiated aspect of it makes it competitive. And then we have the local network, the local internet service provider, where we have very few providers to residential customers. Most residential customers, the vast majority of residential customers, over 90% of the residential customers have one or two providers only giving them residential internet service. And here I will, for most of the paper, I'll use one, which is AT&T, but it could be a cable provider as well. Then the residential customers pay a subscription fee, and they pay directly on the other side of the market to Google, Yahoo, MSN, Disney, some amount of money. Okay, and now the internet service provider wants to introduce fees to the other side of the market, to the provider side of the market. You understand? This is a very basic thing. Try to keep it in mind. Sorry, I don't have a second projector to keep it there all the time. The crucial thing has to do with this S. So many times people talk about this issue as if it's an issue of subscription fees, and I think this is misleading. This is not an issue of subscription fees by users or quantity setups, quantity price discrimination on the side of the users. This is not about quantity price discrimination. This is not like somebody should pay more or less on the side of the user. This is about introducing this S, which has been zero for a long time from the beginning of the internet, and now AT&T says, and not only AT&T, but all the ISPs who want to increase it. Okay, so to make this, to give you the introduction of the story, it starts with a Business Week interview of Ed Whittaker. Ed Whittaker was the head of SBC when SBC was buying AT&T. And he's the guy who managed to defeat the actual AT&T, the previous AT&T long distance, and then absorbed it. So after winning, he says, now this is the last thing I need to do, make sure that these guys, Google, Yahoo, Vonage, and so on, start paying me. Because they say they're using my pipes for free, and I will not let them keep doing that. Well, that's what the quote is. The quote is inaccurate in some sense, not inaccurate because he said it, but it's not correct, right? Because everybody pays on the internet, and people pay, even Google or Disney and so on, they all pay for transmission because they pay the backbone. the backbone collects from both sides. Collects from the local side and from the provider side. So the backbone, a backbone communication contract, somebody who owns a piece of the backbone, writes a contract which is called transit, which says, I'll give you this bandwidth for this price, and I'll deliver the whole internet to you. And they sell this to the ISP of Google, and they sell it on the other side to the local ISP, somebody like AT&T. So they collect from both sides. That's the setup. This is how it has been since the beginning of the internet, the beginning of the commercialization of the internet in '93 or so. Okay, so he's not right about that. People pay him. Okay, so what does he really? Oh, let me skip this for a second. So what does he really want? And I'll come back to those. He wants to abolish this regime of net neutrality in which people pay S equals 0, and in which the providers pay S equals 0, and start charging the providers. The providers being applications providers, content providers, and so on. So that's what they want. Let me go back one slide. So on the other hand, the internet was based on this separation between the hardware and electronics level, the network level, and the applications level, and it's much more decentralized than all digital centralized electronic communication networks. And I see a number of people who are as old as I am, and you remember that the CompuServe, AT&T Mail, Prodigy, and early AOL, where you couldn't really do any network function. You were given a terminal, and all you could do is just type a few words, and all the functions and all the functionality was in the center of the network. Well, the internet is not quite different. So this way that the AT&T proposes is trying to bring more of the functions to itself, or the functions of the internet to itself, and restrict the functions at the edge of the internet, restrict what Google can do, restrict what others can do. Now, this is a problem for the United States because although the internet was invented here and so on, the US is lagging in broadband. Here is the OECD numbers, and they also exclude Hong Kong, which should be over here in the very beginning. The United States is number 15 in broadband coverage. And you see a number of European countries up here, and you also see France. Whenever I give this talk in Washington, people object to this. They don't worry about being 15. They say we're below France. That's a big problem. But it is a very worrisome thing that on something that was created in the United States has low coverage of broadband. And in fact, if you see the same slide with the income level, the per capita income level superimposed, you see that for the vast majority of the countries that are doing better than the United States, they have lower income. There are only a couple of exceptions. Luxembourg, we should really disregard Luxembourg, just bankers and nobody else. I mean, this is a completely disregarded Luxembourg. But what about, and then there is Norway, but everybody else has lower income than the United States. So it's a problem. So because the present internet, without net neutrality, has low penetration. So if we give it, if we say AT&T is right and let them collect, will we do better? And I really doubt it. Okay, so let me go now to something that will appeal to any lawyers who might be in the audience, and will appeal to Kevin too, because he has written on it. The varying levels of net neutrality and what do the words mean. Okay, so, oops. Let me screw this in so this doesn't happen again. Okay, so we're talking about pricing on the other side to the consumers, okay? On the other side of the consumers. So it can mean absolute non-discrimination. What is absolute non-discrimination? It means that you don't allow AT&T or the other networks to offer any quality of service variations, even if they don't charge you. So essentially, this is kind of a hardcore position that Tim Wu has proposed, which essentially says you don't even allow the network to minimize their costs. Because if you don't allow them for free to give prioritization, you don't really allow them to minimize their costs. The second, slightly weaker definition of net neutrality is to say, well, let's allow them to minimize their costs, but there will be no fees charged. So no matter what, there will be no fees charged on the applications and content side of the market. The third possibility, going to more liberalized definitions, is to allow for tiered service. Tiered service means that you create various lanes and you sell them at different prices. Something like what in telecommunications is typically called the tiered, it's called tariff-based telecommunications, in which you have a certain tariff and anybody wants to pick up tariff 1, picks up tariff 1, somebody picks up tariff 2, and so on and so on. But there is no exclusivity or identity-based discrimination, which means that if tariff 1 is let's say a high-price tariff and high quality is offered by AT&T, all of us in the room can have access to it. All of us providers of service in the room can have access to it. Then something that is definitely not considered net neutrality is if we allow identity-based discrimination. Identity-based discrimination means that we have this high-end possibility, but it's only offered to Jonathan and me, and nobody else.
Sounds fair. Sounds familiar.
And then there is the exclusivity in which it's offered just to Jonathan, nobody else. So there is a...
I'm liking this better.
So, and this has been seriously discussed. We created a special lane. We say one of the 3 search providers, either Yahoo, Microsoft, or Google, is going to get it. We will assure you that nobody else gets it. So if it's offered to Google, nobody else gets it. If it's offered to Microsoft, nobody gets it. Okay, so these are the 4 and 5 are definitely not net neutrality. There is a debate if between 2 and 3. 2 is 1 for sure, but probably not. We don't want to do it because it doesn't allow cost minimization. 2 for sure. 3 isn't there or not. So here is Obama's position on net neutrality. So as I say, I feel proud that I played a role in writing this position, and I'm even more happy that it's one of the policies that Obama still has on his website. It hasn't been rescinded, so it's still there. And it's kind of long because lawyers put a lot of effort into it. But the bottom line is, read the thing with black, which essentially says Obama supports the basic principle that network providers should not be allowed to charge fees to privilege the content or applications of some websites and internet applications over others. Now, at the first glance, this looks like number 2. If you look at it carefully, and if you're a good lawyer, you see that it includes number 3 too. So, because it allows essentially tiers as long as each tier is offered across the board. So this is the official position of the Obama administration. Let me skip this one. This is what the proposal of the FCC. I'll skip this too. Let me tell you, there was a proceeding of the FCC. Started in October 2009. Like many proceedings of the FCC, it takes years to finish. It finished in December 2010. And in the end, it had very little of net neutrality in it. And here is what it had. First, transparency. That the network providers should explain to the public, to their customers, what are the performance characteristics, the terms and conditions of the broadband service. 2, no blocking. That is, no broadband provider can block lawful content. Okay? And 3, no unreasonable discrimination. So what's the word unreasonable? So it doesn't say no discrimination. It says no unreasonable discrimination. And unreasonable means that has to be defined, and the lawyers from this side and the other side are going to fight it over, and it will take years to define practically speaking. And okay, so essentially this is a very weak regulation. Why? Because blocking is not really necessary to make the business of Google much worse. If, for example, AT&T tells Google, look, we're not going to block you, but your content is going to go 15 seconds or 20 seconds after Yahoo. So because Yahoo gives us money here, we'll make sure they go immediately. And Google is going to go 20 seconds, 30 seconds, whatever number you have in mind. What's going to happen? Pretty soon, people are going to start switching to Yahoo. There's no blocking involved. It perfectly fits the regulation, but it creates a business problem. And then there is the issue of unreasonable. So this is FTC rule, but even though this regulation is weak, soon after, a couple of weeks later, Verizon sued to stop it, and it's still there. Okay, so I won't go into the details of this directive. This is the directive of the EU. It's even more vague than the FCC directive. I won't go into details. It says we should have strong transparency. We should. I won't go into details of that. It's think of it as in mind that the European Union has not yet decided on this problem, so they have some vague directive out there. So now, given the problem, how do we analyze it? The first thing to see is that the residential ISPs, people like AT&T, Verizon, Comcast, Time Warner, and so on, have market power. Market power means that they are not in a competitive market. They have big market shares. They're usually one or two in these markets. They're able to set prices. They have significant price-to-cost margins. Okay. Now, the residential ISPs claim that the problem that they face is congestion. They say, look, I mean, everything is fine, and we would be very nice not to have net neutrality, and it would be excellent, but we face congestion. So, I have written more than two papers, but let me refer to those two on these issues. The first one, the one with Joachim Tag, essentially shows that if you don't assume congestion, just from the market power that these guys have, they will charge higher prices. They will charge they will charge positive prices to the provider side of the market. And even though network neutrality, zero prices on the provider side of the market is the best for society. So essentially, this is a very simple idea. Network neutrality is the best for society, but the individual incentives of these providers with market power makes them charge a high price. But this is assuming no congestion. So the paper that I distributed is number 2. So essentially, we assume congestion. So essentially, we're getting close to the position that the ISPs want. Okay, we assume that they have congestion, and then we are looking at whether network neutrality is optimal or not. Okay, and as you'll see in a few minutes, we show that under a wide variety of circumstances it's optimal, and then there are some circumstances when it's not optimal. So, okay, so this is the present paper. Okay, so let me, and you'll excuse the mathematics, I'll try to be as non-mathematical as possible. So
light touch mathematics.
Light touch. So you can, in some way, think of the words, think of what I'm saying, and you can ignore the equations. Okay? So that's the best way for a non-mathematical approach. So we assume that the consumers are homogeneous, so they're similar, and we have different types of applications, which the consumers consider some of the applications to be time sensitive and some not, which is actually the truth, right? I mean, email is not time sensitive, but real-time video or real-time voice over IP telecommunications is time sensitive. I mean, you won't be able to do them unless you have, especially voice over IP. I mean, if there is delays, then you say, what's going on? This guy doesn't like what I'm saying, or is it? It's not really. It's just a lie. Okay, so and then we have various providers. So each type of provider provides some information package. So we have, email provider, video provider, voice over IP provider, and so on and so on. And then we have a certain amount of bandwidth. So AT&T has this amount of bandwidth B, which in principle could be subdivided in dedicated lines or pipes, B1 all the way to BG. Okay, so now congestion. Now if you add all the bits that go through and divide by the bandwidth, you have a measure of congestion. So congestion here means a time delay. It's equivalent to a time delay. So if you have a lot of stuff going through, it's going to be delayed to some extent. Now, of course, this depends on the pipe, so we give different pipe possibilities. So if the pipe is wide, then it's delayed less, and so on and so on. Okay, understood that far? Okay. Oh, okay, so this is just for the economists. So this is the... okay, but
there are a few, so you're okay.
Yeah, but I'll explain what's going on here. We define some utility function, some satisfaction function for the consumer, which depends on how much money he pays, which is this part, and how much money he has left over. So what is this utility he gets from the from telecommunications? Well, it's different X's. Remember, the X's are the information packets. So here are the X's. Some of the X's are the X's of Google, and some of the X's are the email, and so on and so on. There are different X's. But then each X is adjusted by a delay function. So this delay function is this alpha function, which depends on the actual delay, which is t, and the type of the provider. So what does this mean? This means that if I look at the Google packets, I might like them a lot and care a lot about the delay too. So I have two different ways to evaluate how much I care about the Google packets in my utility function. One of them is the absolute delay, and the other one is how much I like them. Okay, do you understand? So there is a pretty general setup to try to take into account preferences in a complete way. So some people might have written a simpler thing in which they wouldn't take into account the idiosyncratic, the type impact. But we write something more general. Okay, you understand? So this is a general thing. We have the utility function, we have the information packets, and the utility they gets adjusted by some function of delay and what type of packets these are. Okay, so this is a pretty general setup. I won't talk about the details of the mathematics below. Also, for the moment, don't worry about the equations. What we do in this setup is find out what is the demand function. The demand function means if we gave prices, how much would Google provide? How many packets would they throw in? And if we gave prices again, what would be the email flow? And so on. So we create this demand function, which depends on the delay function and some other functions, which I won't go into details. Now these are the profits of the internet service provider. So he gets some advertising, he collects some money from the consumers, and he has some marginal cost. And oh, I'm sorry, this is the profit function of the provider, not the ISP. I said it the wrong way. So the provider profit, he gets, like Google, gets some advertising Q, gets some money maybe from the consumer's B, has a marginal cost. Here is his demand. Here is what he pays to the ISP. Okay, so we maximize this. If you're Google or anybody else, you would maximize this, and I won't go into the details. But here is the maximized profits, and we can show that these profits are of this particular functional form. This might mean absolutely nothing to most of you, but it's very, very important for the rest of the model to go forward, because it says that the profits of an internet service provider are proportional to some base profit that is defined for everybody, and then they are proportional to the sales. So it's a base profit times sales minus some fee they have to pay to the internet service provider. Okay, more mathematics than I thought you could bear. Economists define something called consumer surplus. You should think of consumer surplus as the value to a market, to the value of the existence to a market to a consumer. So, for example, think of the market for diamonds. I might be willing to pay $1,000 for this diamond. For the same diamond, you might be willing to pay 2, you might be willing to pay 10, and so on. If the clearing market in the world is 1,000, then I am as well off as I could be because I was willing to pay 1,000, that's the clearing market, but him who was willing to pay 2,000 gets a consumer surplus of 2 minus 1, 1,000, and her who was willing to pay 10,000 gets a 10,000 minus 1,000 consumer surplus. So consumer surplus is a way to view the benefit to consumers from a market. So here is the benefit to consumers from a market, and then what we call welfare is the consumer surplus plus the profits of the providers. So in here we have two types of profits. We have profits of the ISP, AT&T, plus we have the profits of the providers like Google, Disney, and so on. So they're all in there. What we show, and this is very important for the rest of the paper, is that this welfare is proportional to the amount of content that goes through the network. This is, we went through a lot of work, which I'm not going to show you, but it's very, very important that the welfare is proportional to the content of sales that come through. Which means that if I want to increase welfare, all I need to do is increase the amount of content that comes through. Okay? So this is crucial. It's not how the content is distributed, it's the total amount of content that increases the satisfaction of society from it. Okay, so this is summarized in proposition 1. Essentially, it says, well, suppose I were to cut the bandwidth into different ways. Okay, so one of them, of course, would be not to cut it all, right? To have it as a homogeneous bandwidth, and another one might be to cut it in pieces or anything like that. It says, given two alternative divisions, the one that satisfies society most is the one where more throughput comes through, more content comes through. And therefore, network neutrality is superior to any division of bandwidth if any division of bandwidth, or no other division of bandwidth, gives you higher content in equilibrium. So if I can show that not dividing the bandwidth gives me more content coming through, then I have proved net neutrality is the best. Do you understand? So this is kind of a convoluted way, but we got there, right? So we want to show if net neutrality is the best. How do we do that? We find that welfare is proportional to content coming through. To maximize the content, I need to show that net neutrality regulation increases content. Okay, so far? Yes?
If you had two, so you say the amount of content, you want to maximize, Google wants to maximize the amount of content that they're sending. Would an HD movie and a standard definition movie, one using more bandwidth, but charging the same amount, how would that?
We haven't gotten that far. Okay. Hold on for 5 minutes, because we haven't gotten that far. For the moment, all we have done is to say how we might be able to cut the bandwidth to increase welfare. I'll get to prices in a moment and how we actually cut the bandwidth. But wait for 5 minutes. Yes.
Some consumers might say that certain content actually has a negative contribution to welfare. For example, spam. But in your model, I take it every little bit of content, no matter how perverse, is welfare.
I wouldn't mind doing your thing. I mean, in terms of from the economist's point of view, I could find some way to adjust this function so that there is some type of content that you really hate. So throw it out. But I haven't thought of it, but I mean, we haven't included it in the paper, but I think it will be very simple to actually adjust it to do that. And thank you for doing this, because we have a couple of weeks to submit the revision, so you might as well add it in. Okay. Okay, so here we are. We defined how net neutrality could be welfare superior. Okay, so in economics terms, the amount of content carried is a sufficient statistic for welfare. How the bandwidth is allocated does not affect this. And if I can give you some intuition about it, it's like content is analogous to income. And the maximum effect when I give you more income is to let you spend it any way you want. If I start giving you restrictions, most likely you will be worse off. So it's very similar to what's going on here. Okay, restrictions, special lanes, and so on restrict welfare. In other note, maybe to economists only, this is a reminiscent of some early work by Varian, who showed that third-degree price discrimination increase in welfare compared to uniform pricing happened only when there were increases in the total amount of goods sold. I think you should disregard this. This is not to economists and not to anybody else. Okay, so and what we go further on to show is that if we were to have an ISP who might start charging money, he will start excluding some providers. Now, who would he exclude? He would exclude the low providers, the low theta providers, the low types of providers, the ones you don't care so much about. Okay? But if he starts excluding people, excluding providers, then the welfare would decrease. So the welfare would be less than if no content providers were excluded. It's kind of almost obvious from the previous result. Okay, so okay, let me go up to here. Okay, here, back to here, no mathematics. Okay, so now the major question. Suppose I arbitrarily start dividing the bandwidth what would be the best way to divide it to maximize welfare? W. Remember, welfare is the consumer surplus plus profits of all the providers. So essentially the question is, if I do that, which packet should be sent faster? Or maybe I should do net neutrality, in which no packets are sent faster. But if I don't do net neutrality, which packet should I send faster? And how much faster? So it's actually an actual question there. Okay, so it turns out that this depends on this particular delay, the optimal delay. So if I am to cut the bandwidth, I would have to tell people like Google, you are in this bandwidth, email is in this bandwidth, voice over IP is in bandwidth, and so on and so on. And define the optimal delay, okay? So it's pretty complicated to prove, but network neutrality turns out to be the optimal thing to do and not prioritize anything for some wide class of utility functions. And I'll explain which ones they are. And otherwise, you might want to prioritize. Let me explain. Let me give you the intuition instead of the mathematics. So assume that originally we had two different types of content. And we gave them same prioritization. It's the same time delivery, okay? No prioritization, whatever, same time delivery. But then we looked at the time elasticity of demand for this particular content. What is the time elasticity of demand? Take demand and say, how does this vary with the time of this particular content? It sounds a bit esoteric, but economists use widely the idea of elasticity. How sensitive are things, quantities, to changes in prices? But here we don't do price changes, we do time changes. So we make content be a bit slower or a bit faster and see what effect it has. And then we see how this elasticity varies with the type of content. So we suppose we have higher elasticity of demand for theta rather than theta prime. Then clearly shifting the content from theta prime to theta would increase the volume of trade. So we just look at the elasticities, see which one is better, move it that way. So that's essentially what we do. The network neutrality is optimal when the delay function takes this form. This is a pretty general form. Let me explain what it means. It has these multiplicative factors. So it has the time delay times some function of the time delay times some function of the type of content. So essentially, it means that your preference or lack of preference for delay is independent of the type of content. So it's kind of multiplicative. So they're not a much more convoluted function which takes both theta and theta together. Okay? So when we started writing this paper, we had thought that this was such a general form that we didn't need to think of anything else. In the revision, guided by the referees, they told us, look, I mean, maybe there is another functional form. So now we wrote this paper has been rewritten essentially from scratch, using the more general forms where this is kind of a very special case. I actually think this is pretty general. So for most cases, you're probably going to do this rather than something else. Okay, I'll skip this, the proposition. The proposition essentially says what I was telling you before, that you look at the which one, the previous intuition, which one has higher, which type of content has higher time elasticity of demand, and you give it prioritization. It turns out, and I won't go into detail on that, that sometimes you want to prioritize the content that people desire most, but sometimes you might want to prioritize the content that people desire the least. because direct desire is not exactly the same as the effect on the elasticity. This is very esoteric. I'm not going to go into that, but we have particular functional forms in the paper that show that sometimes you might want to delay the things that people want quickly. The reason for these things being so convoluted is because we have always adjusted demand according to whatever bandwidth you give. So think of a freeway in which you're going to cut up the lanes in a certain way, but then you allow people to recongest. Then you will see that even the fast lanes get get recongested. Okay, so now having done that, the question is, what would an ISP do? Do I have 5 minutes? Yeah. Okay. If an ISP,
Just 5.
5. Okay, exactly 5.
Exactly 5.
Okay, I have 4 slides. I'll do it 5 minutes. Okay, so it's fine. The ISP, the internet service provider, what would he do, given what we want? Well, for reasonable conditions, which we state here, then we say any price discrimination scheme that the ISP might implement is going to be welfare inferior to network neutrality. So up to here, we have analyzed what's optimal things. Okay, net neutrality, not net neutrality, but optimal things. And now we allow this guy to start charging money. Okay, and what is he going to choose? We find out that in the general conditions, he doesn't want to go towards net neutrality. Okay, so here's another way to say it. Given these general functional forms, the residential ISP will strictly prefer not to implement net neutrality. And will, of course, means that he will choose prices that will not, he will choose an allocation scheme and prices that will not result in net neutrality. Okay, so far we have dealt with a static problem. Static problem means we didn't allow investment in bandwidth. And that's the second objection of AT&T. AT&T comes and says, look, I mean, if we don't have net neutrality, we'll be poor. Now, it doesn't make sense that they are poor, but they're still bidding $39 billion for T-Mobile, but they still say we're going to be poor, and therefore we're not going to be able to invest in bandwidth. So we allow people to invest in bandwidth. Okay? So as you expect, an unconstrained, non-regulated ISP without net neutrality will typically invest more in bandwidth. And more bandwidth alleviates some of the static distortion. What do we mean by that? We said the ISP doesn't want net neutrality. Net neutrality is optimal, but if we allow him more bandwidth, the fact that there is more bandwidth takes away some of the problems of being not constrained to net neutrality. So, and here we have an example, which is in the paper, which says essentially, this is the consumer surplus, how much consumers get, these are the profits. So if the balance of consumer surplus to profits are more than 1.32, I mean, this particular number here, then net neutrality is better. If it's less, net neutrality is worse. So essentially you should take it, it can go either way. Okay, so there is, I think that if there is any validity to any theory against net neutrality, this is based on these dynamics. That if you allow people to make more profits because they're unconstrained, they're going to invest more on bandwidth, and that might alleviate all the effects. Usually not all, but sometimes all the effects. Okay, extensions. These are really esoteric, and I'm not going to go into them in detail. We discuss pricing per unit. Before, up to this point, we're pricing per ISP, per provider. Now we're going to price per unit, like per click or something, or per information packet. And we can see that this doesn't make a big difference. In fact, it supports the main results. We have heterogeneous households. The households consume different amounts of information packets, and that also work through. We have content providers with various margins, because before we had them all with the same profit margins. We have a generalization of a utility function, other utility functions, and the main results go through. So, basic conclusion. Okay. Under reasonable assumptions, welfare increases in the total amount of content carried. So that's kind of the big setup of our results. Because if this didn't work through, all the other stuff would be ambiguous. So this works through, we can go forward. So we have a general setup from which we managed to prove that welfare increases the total amount carried, even in the presence of congestion. And we can also show that even in the presence of congestion, net neutrality can maximize welfare, and there is specific condition on that. If the elasticity of demand with respect to transmission time is invariant with respect to the particular content, to particular type of content. But it's possible also that depending on this elasticity, you might want to prioritize content of high immediacy desire. And then finally, killing net neutrality can increase bandwidth investment and reduce the static allocative efficiency. So, okay, to give you to finish on time, okay, so we started with a general idea of network neutrality, okay, what it means and so on and so on. And we discussed really essentially two models. The second model, which was under time congestion. The previous work that I think I presented here 3 years ago was talking about no congestion and dealing with this problem from a pure power, market power point of view. And we see that even if there is congestion, except for the issue of bandwidth investment, net neutrality typically maximizes welfare. Thank you very much. I'm on time.
Our benefit of having Nick, there are twice as many words said in this 45 minutes in any 45 minutes of comparable time I know. We do have time for questions for a few minutes. Please.
Yes. Do you want the mic? When you come here?
This mic.
Okay. Then you sit down.
Hello? I'm Lucy, but I don't need a mic.
Well, she projects well.
I'm a boomer in all senses of the word. The question was raised about cost of content, and of course the basis of the model has to be equal validity of content, but obviously you're at the Annenberg School of Communication and USC that focuses on a lot of different types of content. One type that's sweeping the US and the world is Netflix, which is a very efficient, consumer-friendly distribution model for big pieces of content, i.e. movies. So how does that work? And it's obviously in a future iteration of your model where not only people are paying $10, $15 a month for this content, but they're subscribing to it, they're connected to it, and so on. How does that work in your structure?
Okay, I think the structure works fine with that. The only problem, and that's a real world problem, and it's also difficult to model, is that the present service provided by the cable networks and AT&T is a best effort service. They don't really sell you this particular bandwidth. They say, oh, we can do up to this. Well, but it could be this, but we can do up to this. So which means that, first of all, it's impossible, practically impossible to model, because the model has to be a certain amount of things that we sell you, not some kind of random distribution. It might be so, it might be this, and so on. Second, if the ISPs were to offer you the max, then there would be no problem whatsoever with delivering Netflix to everybody. But the problem is that the networks are set up in a way with the expectation that only few people consume the maximum. So once then there is a real problem with them that they might be severely congested. And then they would need more investment in bandwidth. The difficulty is that bandwidth investment is not linear. That is, you cannot just say, well, I'm going to spend 10% more money and I'm going to get 10% more bandwidth. Because there are only the very limited number of technologies. There is copper wire, there is coaxial cable, and there is fiber, and there might be some versions of wireless. Okay, and that's it. In cellular communications, you can increase the number of bandwidth, the amount of bandwidth through proportional investments, and that's fair. But in fixed telecommunications, you cannot do that. So if AT&T is trying, suppose AT&T gets really congested, no matter how much money it collects, and suppose it kills net neutrality and collects more money. The only way to go up is to go to a higher generation network, to go to fiber or something different. But Verizon, to some extent, in some areas of the East Coast, and I don't know about here, but some areas of the East Coast, they have gone to fiber. But then their main model is not to sell you internet service, but to sell you video. And the main model, similarly, of AT&T is not to sell you internet service, but to sell you telecom. So the internet provision suffers as well from this. So I don't see an easy way out of this, if you put it that way. I don't see an easy way, because the technology doesn't allow for an easy
Flexibility in terms
Flexibility.
of consumer preference changing.
That's right. Or flexibility to significantly, to very significant increase in content. Because if we all start downloading Netflix, that's going to be very problematic.
Well, that is what that's happening.
Well,
It is
you know,
very
to give
problematic.
a specific example, I've been talking a little bit with the head of CRTC, the Canadian FCC, is a fellow with a quite wonderful name of Conrad von Finkenstein. That really is his name. And he told me that right now, in prime evening hours, they have 78% of Canadians are using Netflix, and that streaming Netflix from the 7 to 8% who have adopted it, obviously mostly the kids, is taking 20% of his bandwidth.
I mean, a real solution might be what the Koreans did with a push on Ethernet-based, fiber-based telecommunications, or what they have done in Hong Kong, or essentially practically every household has fiber-based stuff. But this requires some investment, and it also might involve the government. I mean, this is such basic infrastructure that it wouldn't be insane for the government to subsidize it. Like they subsidize roads. I mean, you know, come on.
And some like Australia are doing that, and to some extent Brazil are doing that in a big-time way.
What do you think about the emphasis that the FCC sometimes places on rural communications? And I know they kind of study that and measure that, and it seems like maybe sometimes that might be a distraction when so many of the users are in more urban centers.
I completely agree with you. I mean, it's a more of a political economy type of issue because of the disproportionate representation that rural areas have. And so they have more of a say. And to some extent, in traditional telecommunications, it has been used by the traditional telecommunication companies like AT&T and Verizon as a way to keep the price structure from changing. Because here we have the internet and a very, very low cost of transmission, but suddenly you look at the price of phone calls from Verizon and from AT&T, and they look pretty high. You say, what's going on? Why are these prices not following costs? And part of it is because of all this extra infrastructure of subsidizing the rural areas, which has been exploited very ingeniously by these companies to make sure that prices don't change. I actually don't see it as a big problem, but at the same time, it's kind of a political economy issue more than anything else.
Kevin, 1, 2, 3, 4.
Well, my question is about a certain assumption that has to be baked into the model, which is about a kind of a fixity in terms of who is a content provider and who is a potential consumer. And this does point a little bit to the congestion issue of Netflix, which is that in any given moment, conceivably, one of the users could take on the role of the content provider, but their contracts that they have with the ISPs suggest otherwise, that there is more of a fixed relationship.
I think that's true. I mean, that can happen, but it's rare. I mean, it's very rare. I mean, even with all the downloads from my Economics of Networks website, I'm hardly a provider. I'm a tiny provider still. I mean, it can happen, but it's small. And the number of people who run servers is also very small. I mean, how many of you run servers here? Okay, that's so very small percentage. 1%, 2%, yeah.
Well, could I just clarify my question, which is that in the Netflix case, it seems like Netflix is dominant in the English-speaking communities primarily, and I've seen similar services that provide a similar user experience, but using a peer-to-peer kind of technology, such that lots of people would be in the role of a server, but may not even realize that they are a server in that moment. Similar to the way that lots of PC gaming might work behind the scenes, that from a user experience they feel like a client, but actually they're serving a significant amount of data to their peers.
Yeah, if they run BitTorrent or something like that, that's possible. But I think the fact that Netflix, you said, has a more dominant position among English speakers, I'm not surprised by that. I have another paper with Brian Viard on the digital divide, and one of the things that we find, and I should say, and Katya Sen also, and Katya Sen is in New York, and Brian Viard is in China, in Beijing. We show, one of the things we find is that the Spanish-speaking people who speak Spanish, Hispanic descent people who speak Spanish at home, have much less penetration in broadband than anybody else. So I'm not surprised that you say that about Netflix. I mean, this kind of confirms what I say. But if you're interested in this digital divide issue, please take a look at those papers. There are two different papers. One is for worldwide digital divide. One of them is U.S. digital divide. And these are kind of harder papers because they're econometrics papers. But if you can get something. Sorry, I don't want to.
I have a somewhat theoretical question.
Please speak
I
up.
have a theoretical question. If I understand correctly, your model is typical prescriptive or normative model, and suggesting the optimal solution for multivariate optimization problem, right? So your final conclusion is allow the ISP extend freely the network as far as they can. So my question is, however, according to the theories of the complex network, so networks do not grow evenly or uniformly. But they, even in the natural setting, they grow into a biased one, like a scale-free network, power law network, or the small world network, which means if we let them, the provider extend freely, then the network itself does not go to in a neutral way. Something like the program that grow into the biased one. So how would you combine the emergence of the biased network and the concept of the natural neutrality?
The emergence of what? The emergence of the
biased network.
Of the FiOS. Well, I think I'll go back to my previous answer that a lot of the FiOS as installed in the United States was basically for video and not for internet-related stuff. So Verizon, when they come to you and say, look, I have FiOS, you give your FiOS system, they say, okay, here we give you FiOS with 500 channels and this amount of internet. Now, if the focus of theirs was on internet, they would say, we'll give you this huge amount of internet, which you can cut in any way you want and watch any channel you want. And in fact, given the big amount of internet, you could watch many high-definition channels at once. They don't do that. They give you specific channels. And then they give you some amount of internet which may or may not be sufficient to watch a high-definition TV channel. So I think it's the focus of the companies is on other products and not on internet provision. All the providers have a different focus. So I'm not going to go into more or less on the power law and all that stuff that you said because I don't see it too relevant to this, to what I'm doing here. We can talk about it later. Let's put it that way. I would like to talk about it, but not in this. Yeah.
Okay, two more questions.
So if the case can be made that this is a serious social welfare issue, then presumably it would be the government's responsibility since the corporations don't have an incentive to take care of this. It would be the government's responsibility, and then presumably they would do that through the FCC. Do you think the FCC in its current formation has the incentive or even the ability to enforce this?
Well, the FCC is just a regulatory agency. I mean, if there is a program that would push for more internet broadband, this has to come from special legislation of Congress. This has to come through a type of industrial policy which the US lacks in general, to say that, look, I mean, we think that the internet is important enough that we're going to spend some money on it like we spend money on roads. And then, like all the other compromises, there will be an issue of how much is spent by the federal government and how much is spent by the state government and so on and so on. But in the present state of affairs in Congress, I think it's unlikely. Let's put it that way, very unlikely. So this is going to go through, although it's necessary. I think that the problem is that politicians have very short horizons. And this kind of issues where the horizon is longer and the benefits are going to accrue over a long period of time tend to be disregarded by politicians everywhere.
Francois, and then Peter has an announcement.
I was wondering what part of the model depends on the fact that it's such a safe market, and which parts would fall if you're just talking about congestion on airplanes. in back of my
I
mind.
mean, we could restrict it so that it's a one-sided market and just write a pure congestion transmission model. I haven't thought extensively of how to restrict it to one-sided, but I think it should be easy because all I need to do is just set up some parameters to 0.
But I wasn't seeing exactly which part of the model require the two-sided.
Well, because the two-sided comes from this S. Okay. Here, there are these. Okay, hold on a second.
But the S is a one-sided towards the provider, isn't it, essentially? So you could you don't have the price, you don't have the whatever this Greek letter is, the subscription price within the model, right?
Yeah.
So you're thinking of a one-sided upstream market, the ISPs to the Google, Yahoo, and CNN.
No, I have all these three. Right? There are three prices there. I mean, maybe they don't have the same symbols as here, but there are three prices. There are direct subscription prices to the ISP. There is a price that goes here from the from the residential customer to directly to these guys, and there is also this fee that goes this way from Google to AT&T. And we also have something that's not written here. We also have an advertising revenue that comes in here out of nowhere, right? I mean, for the advertisers, not really modeled so much in the market. No, we do have it. So I could really, delete a couple of the prices and make it a one-sided model. It will be much simpler. I think that the same results will go through. And I don't know if you read the extensions. If you go near the end of the paper and read the extensions, we also sometimes allow for another price. We call it a raw. And the raw is a per unit price directly from Google to AT&T. So kind of more refined in some sense because we're charging the same as for everyone. Sorry.
Okay, we've reached the end of this. Peter has a note, and then we'll thank.
Yes, our speaker next week is John Durham Peters from the University of Iowa, and the title of his talk is 2 Cheers for Technological Determinism. Come here, John, next week.
Thank you, and thank you.